Okay, hey y'all. Let's go ahead and finish those 10.5 problems. If it will open, here we go. Okay, so the problem says to find the measure of each marked angle. If you notice, I have a straight line. That tells me that these angles are supplementary. Just a little recap. Supplementary angles. They have a sum of 180 degrees, and they can be represented with a straight line. An angle could go like this. The angle could go like that. The angle could go like this. What I want you to recognize is just that straight line. And then we have complementary angles. Complementary. They have a sum of 90 degrees. And that's going to be an L shape right there. You usually see our right angle symbol, which is a box. That's where those two angles meet. And the angles that we could be talking about there could look similar to that, or this, or this. It really doesn't matter where that additional line is drawn, as long as you understand that the angles that make up that straight line equal 180, and the sum of the angles that make up this L-shaped is going to be 90 degrees. Okay, so let's scoot over this way. So I noticed that I've got a straight line that first and foremost tells me that my equation is going to equal 180. I'm actually going to draw it on the left-hand side. It really doesn't matter where it is. The fact that we write an equal sign means that you can write it either way. Like I said, supplementary angles have a sum of 180 degrees. So right there, plus. I'm literally going to take the expression on the left-hand side, and I'm going to take the expression on the right-hand side, and I'm going to take their sum, which means I'm going to add them together. I don't see any negative signs, no subtraction signs, so I can literally just bring down each term of both of those expressions. On the right-hand side, I notice the like terms of 19, why did I say 19? Of 9x and 13x. So left-hand side, I get 180 equals. If I combine 13 and 9, signs are the same. So I would add and get 22. And then you keep your variable, keep your exponent. And then also, if you notice, I've got a 1 and I've got a 3. Signs are the same, which means you would add and get 4, and you would keep their sign, which is positive. And then I would need to move my 4. I would do the inverse of a positive 4, which is a negative 4. Whatever you do to one side, you have to do to the other. If you combine a 180 and a negative 4, those signs are different, so you would subtract and keep the sign of the larger, so I'd get 176 equals 22x. Those went away, right, y'all? Now, we don't need to do that just yet. Now, I noticed that my x is being multiplied by a 22. In order to solve for my x, I do the inverse or the opposite because it's being multiplied by a 22. The inverse of multiplication is division. I would divide by 22. Whatever you do to one side, you have to do to the other. And so this is where I'm going to get my calculator. Let me clear that, 176 divided by 22. I get 8. Open this back up. Okay, and then let me go right here, y'all. 176 divided by 22 is 8 equals, those right there, those cancel, right? 22 divided by 22, that equals 1. I did that on purpose. So, am I done with this problem? No, I'm not done with this problem. I actually need to take the fact that I just now learned that my x equals 8, and I need to plug it in to these two expressions right here. So I get that the measure of each angle are Okay, so technically, I don't have it written here, but one angle is going to be larger than the other. So in your homework, it may say the larger angle is, and then the smaller angle is. Whatever has, here, let me just show you. It'll make more sense. Okay, let's plug in here. 13 times 8 plus 1 equals. So 13 times 8 would be 80, 104. Let's do it here. I don't want to be wrong. 13 times 8 equals, yes, 104. So 104 plus 1 is 105 degrees, correct? And then let's plug in here. I get 9 times 8 plus 3. 9 times 8 is 72 plus 3 is 73, 74, 75. Question, and that's degrees, right? If it asks you which is your larger angle, whatever that is, largest angle, that would be the 105, correct? Then if it asks which is the sum of your smallest angle or the actual measure, that would be the 75. Now, you could also check here just to make sure that you plug these in correct. I know that the sum of supplementary angles equals 180. What do you get if you add 105 and 75? 180. So those would be your answers to that problem right there. Okay, now let's solve some of these. These are literally exactly like what we've been doing since the beginning of the semester. The only difference is instead of them having numbers and maybe a few variables, usually x, and we're solving for x, these problems, these would be considered abstract equations because instead of having numerical values and a few variables, or even just one variable, and we solve for that one variable, these problems have the majority of just variables. So even though they look different, our process for solving them will be the exact same that we've learned thus far. So for this problem, it says solve for J. Our equation is D equals JN. If I'm solving for a variable, just like I did here, right? When my x was being multiplied by 22, I did the inverse, right? I divided by 22. Use that same train of thought. I'm going to rewrite this just so it's a little bit bigger. D equals JN. Solve for J. What's going on around my J? My J is being multiplied by an N. I need to do the inverse of multiplication, which is division. Whatever you do to one side, you have to do to the other. Y'all have to really keep in mind here about things being like and not being alike, because you can only do certain math on things that are alike, right? If you notice on that left-hand side, D divided by N, those are not the same variables. I can't actually do math there, okay? That is literally just D over N equals. But if you look on the right-hand side, I divided for a reason. I'm trying to solve for J, and it was being multiplied by N. So I divided by N because N divided by N, those become 1. Technically, it cancels. So the only thing I have left is just J. So the answer for J is D over N. Okay, let's do this one. This is very similar to the one we just did. It says to solve for U, and our equation is B equals H in U. Okay, so here I actually have two variables multiplying my U. I know division is the inverse of multiplication. I just want you to learn here that you're not going to divide by 1 and then try to divide again, because now we're dealing with dividing by fractions and it could just get very ugly very quickly, okay? Because all of these terms are multiplying each other and there's multiple terms multiplying my U, I know that the opposite of multiplication is division. I'm going to divide U by both terms, h and n. What you do to one side, you have to do to the other. On the left-hand side, b divided by h times n is just b divided by h times n. I can't cancel anything. There's nothing that's alike. Right-hand side, do you see how all of those canceled? I wanted that because all I have left is just my u. So the answer to u is b divided by h times n. Okay, so this one says solve for v. I tried to just kind of write things in here. I'm going to rewrite it so you see it. This is b equals 1 over 8 pi t squared v. So this is saying b equals 1/8 pi t squared v. Solve for v. Okay, well, what's going on around my v? Well, it looks like it's being multiplied by a pi and a t squared. So I definitely want to divide by that. But I wouldn't want to do this and just divide here, right? Because that gives me a fraction in the numerator, and I don't really know how to deal with that right now. So instead, I want to get rid of that 1 over 8. And we've done this. If you have a fraction multiplying a variable and you kind of want to like clear that fraction or get rid of that fraction, what we did was we multiplied by the denominator, right? And what you do to one side, you have to do to the other. So if you do 8 times b, I get 8b equals the 8 here cancels this 8 here. And if you notice, the only thing I have left is 1 times pi times t squared times v, which is just pi t squared v. Still trying to solve for v. Now I notice it's being multiplied by pi t squared. You do the inverse, which is division. By divide by pi t squared, what you do to one side, you have to do to the other. Nothing on the left-hand side can cancel. So this means that my answer, let me just write this. My answer on the left-hand side is 8b over pi t squared v equals pi's canceled, t squared's canceled. All I get left is v. And I apologize for saying that. It's just pi t squared. There's not a v on the left-hand side, y'all. Okay, almost last problem. Second to last problem. Solve for x. Let me rewrite this. I have b times x plus h times y equals j. Solve for x. I'm solving for x. Okay, I notice that x is being multiplied by b, and I also see that there's an hy being added to x. Because I'm solving for my x and I want to move things away from it, you're going to do what's easiest as far as like mathematically the process you would follow. And here, because my b is multiplying my x, that would be division, right? But if I just divided everything by b, that's the only thing canceling. It's not doing anything for that. So you don't just divide. We're going to do what's the easiest. And that hy is adding to our x. The easiest thing mathematically wouldn't be division, but it would be subtraction. And what you do to one side, you have to do to the other, right? So on the left-hand side, I have bx, those canceled, equals right here. Those are not like terms, so I can't combine them, but I can write them next to each other, right? And then if we continue further, solving for my x, because it's being multiplied by my b, now we would divide. And what you do to one side, you have to do to the other. Do you notice how those canceled? And I was just left with an x equals. On the right side, I have j minus hy over b. Okay, last problem. We have c equals 4 over 5 times k minus 35. Now what we would do, since this 4/5 is touching parentheses, that implies multiplication, we have C equals 4 over 5 times K is 4 over 5K. And then we have a minus sign. Let's do parentheses now because I'm going to actually show you each step. 4 over 5 times 35. So I get C equals 4/5 K. And then here, that can be written over 1, right? 5 goes into 5 one time. 5 goes into 5 7. I'm sorry, 5 goes into 35 7 times. So what I actually have is a top minus. That is 4 times 7. So C equals 4 over 5K. 4 times 7 is 28. Signs are different, so it's negative. And that it says solve for K. And that is not your final answer just yet. So solving for my K, I need to move my 28, which would be a plus 28, plus 28. I get C plus 28 equals 4/5 K. And then last step would be to cancel that fraction. And the way I would do that is so technically what I would do is multiply by the reciprocal, which would be 5 over 4, because there is something in the numerator. It's not just a 1. And what you do to one side, you have to do to the other. And so I would get 5 over 4 times C plus 28 equals 4's canceled, 5 canceled. I'm just left with K. And then I don't know if they would consider this a fully solved problem. So we could go ahead and distribute that 5/4 in. And if you do 5 over 4 times 28, 4 divides 4 one time, 4 divides 28 7 times, and then you just do the 5 times 7. 5 times 7 is 35 equals K. This is the fully distributed answer. The one right before it, I know I marked stuff out, but the answer right before it could probably also qualify as an answer. It's going to look kind of like that form with a fraction multiplying a set of parentheses. Okay, y'all, if you have any questions, make sure you ask, okay? Thanks. Bye.